So Michael asked me to kind of do not a real extensive introduction to Git, but kind of just quick problem solving for things that you're likely to run into that tend to befuddle a lot of new users. How many people here have actually used Git for a project before? Okay, it's about half. How many are using it right now in day-to-day work? Yeah, about 4 or 5. Okay. I know you do.
Sort of.
You're trying to deny it. I know. All right. Okay, so how many of you used the Git command line interface versus, say, the integration with Eclipse or other tools? Oh, one brave soul. All right. Okay, so I'm actually going to show you guys a little bit about the command line interface just because it's common. Anywhere you've got Git, you'll have the command line interface available to you. Different tools integrated in different ways, so I figure let's go with common ground. And frankly, I find sometimes it's the easiest way to just quickly get some information in a way you know will be the same anywhere you go. So some quick preliminaries. If you've ever had to play with the configuration of your Git installation, this might look somewhat familiar, or if you've ever done any work on Windows machines, they use a pretty similar format for some of their configuration files. There are basically 3 places you can configure. There will be a .git config file that'll be in your home directory that'll set per user settings. There's also a system level one that'll set some basic defaults that most people probably don't modify that. And then you can also set certain things per repository. So the ones that you definitely, absolutely, really need to set before you ever start using Git, and usually the tools that you're using with Git will set this up. So the first time you try to use Git through Eclipse, for instance, it will prompt you for your username and your email address. And the reason that's important is that when you go to check code into the repository, it'll stamp every commit that you make with your name and email address, so that when you push that out to other people, people know where that code came from. So that's it. So basically, yeah, these bracketed things here are sections within the file, and then it's just name value pairs. I have found that it's useful to be able to set this to a default at the user level, but then within individual repositories, if I'm working on projects for different people, sometimes I'll work for a company that gives me an email address in their domain that I use for interacting with them. So occasionally I'll want to put a different email address on the commits that I make through a certain repository that's going to be synchronized with a certain group of people. So knowing that you can make those changes. There's the file is named almost identically within your repository. You'll be familiar with the .git folder that's inside of every repository. So the top level folder has at least on Unix systems, it's a hidden folder. Anything that starts with a period is hidden, called .git, and all of the metadata and all of the structure of the repository is in that folder, whereas everything else is your working copy of the files that you're working on. So within that folder, there's actually, within the .git folder, if you just put a slash in between git and config here, there's a file called config that sets the repository level settings. And pretty much anything that you can set here, you can override per repository if you need to. So there are a few things in here that I put in. In the core section, you can set a per user excludes file. Oftentimes a repository will have certain file patterns that it will instruct Git to always ignore. Backup files, certain compiled files if you're compiling a program, a project based on C, for instance, the object files that the compiler creates, and things that you don't want checked into your repository. Occasionally I found it's useful to set this on a per user basis. So for instance, if you use a particular editor and your editor has a convention for the temporary files that it saves for backups as you're working, things like that, you might want to set that differently for your setup versus what everyone else on the team is using, things like that. So you can basically just give it the name of the file. In this case, I'm using the tilde notation that Git understands and will translate to your home folder, just like the $home variable will work on most platforms as well. These god-awful looking things right here are format strings, primarily used when you're looking at logs. So you can go back and say, show me the last 10 commits that have happened on this branch. Usually you'll want to see information about the date and time, who made that commit, and a brief snippet of the commit message so you understand what that commit is for. I just set these up because I think I based these on ones I found online, but this setting right here picks one by default that it uses for the log command. I just called it rainbow because, well, you'll see in a minute why I call it that. I like to use color to make it easier to pick out which parts of the line correspond to which pieces of information. And the reason I do that is by default, if you run the git log command, it dumps the full commit message, and basically each commit can take up half a screen. So if you want to get a quick snapshot of, like, you know, the last 10 commits or something like that, it's going to roll right off the screen. I prefer to see a quick little one or two line synopsis for each one. And if I really want to see more detail, then I've created an alias, which I'll explain in just a minute, for the more full-blown version of it. And basically, looking at your logs is going to be a key tool for getting yourself out of trouble when things don't go quite the way you expect them. So yeah, these are just several different formats. I'll show you what this one looks like in just a minute. The tree format is similar, just provides a little bit of extra information. And then the date format I use very rarely, but it has a more concise specification of exactly what the date was. By default, Git will use something like, try and make it human readable, like this commit was 3 days ago. Well, if I want to know exactly what time of the day that commit went in, I can use this other format and give you a little more detail. And finally, I think this is probably one of the most important for my purposes. The alias section allows you to set up, basically, think of them like macros or user-defined commands. So the Git user interface, the command line interface, you type the word, the Git command, and then a space, and then the overall command that you're trying to run. So commit, checkout, so on and so forth. These basically create new commands that you can specify for that first word. So I just create some shortcuts for the status command. I just call it stat. And this just gives me a more concise, shorter version of it, but always includes information about which branch I'm on, so I can quickly tell which branch am I on and what files have changed. I'll show you an example of that. And I put this one kind of grayed out because I actually have two versions of this alias, one with this last option, one without, and that just toggles whether it shows me untracked files, which basically are any files that have shown up in my repository that I haven't told Git about yet. Temporary files that might get created, or test data that I'm working with and things like that. Sometimes if I have a lot of that stuff that's accumulated that I am not ready to clear out yet, I don't want Git to tell me about it every single time I run this command. So I'll occasionally use that one to just get a more concise. Just tell me about the files that are actually under version control. And then these are just variations on the log command. So this is the one I mentioned earlier that gives me the medium format is the kind of default one that it comes without a box. And these two here, I'll show examples of shortly here, but this one just gives me a little bit more information. I'll explain that in a minute, and shows me kind of the graph of how the different commits into the repository are related to each other. So I provide this, and we're going to make sure we make these slides available on the GDG website so you guys can come in here, and this is all text-based, so you can just copy and paste any of this stuff that you find useful into your own configuration files. So, let's see, it's going to be a little hard to, yeah, the red is not showing up too well, it's a little dark here. But basically, so what Git, I don't want to go into too much detail about the underlying structure that Git uses to track files, but ultimately when you do a check-in or a commit using Git's terms, what it's really doing is it's making a snapshot of your entire structure, all the directories and all the files. A lot of version control systems will start with whatever initial commit you give it and then do a series of deltas. Git kind of does it the other way around. It basically takes a full snapshot of everything every time you commit. It does it in a very efficient manner, and it reuses files that haven't changed and things like that, so it can ultimately store it in a very compact format. But really, if you want to see the differences between two commits and whatnot, it'll just calculate that on the fly when you ask for it. So what it ends up doing is creating this graph type of structure. So each one of these boxes, the gray and green ones here, color-coded these so we can keep track as this graph evolves as we work along here. These all represent what Git calls commits. And a commit is, like I said, a snapshot of what your files look like at a particular point in time when you committed to the repository, as well as metadata about what time you made that commit, who made it, the log message that you type in to explain what set of changes you made with this commit, and so forth. The commit also keeps track of which commit came prior to, which one it builds on top of. So this one here, in the example that I'm going to go through in a minute here, represents the very first commit that I made to the repository when I put my file that I'm going to be showing as an example here in. And then this sequence of commits, each one points back to the one that it derives from. So this represents a set of changes on top of the initial ones that I did here. This one's a set of changes on top of that one, and so forth. And this represents a separate branch of development. The yellow boxes here represent tags, which are immutable pointers into this graph. So at some point along the way here, when I did my initial commit, I decided that this commit represented version 1.0 of my product. So I went ahead and created a tag at that point, and that tag will continue, and unless I go in and tell Git to forcibly change that tag, which generally don't want to do in most cases. We want these things to be forever. It will continue pointing to that snapshot of files. Blue boxes, on the other hand, are what we call branches. And branches and tags are very similar because they're both just pointers into this structure, but branches will move as you make changes. So I actually, master is the default branch that Git will create for you. So when I created this initial commit, master was pointing there. And when I made this commit to do a bug fix, it automatically moved that pointer to the new commit when I created it. And when I decided to create a development branch, which I call dev, it initially also pointed to this location. And then as I committed a series of changes on that branch, it automatically moved that pointer for me. The last one here is what's known as the head. And head basically represents whatever you're working on at the moment. Head represents what's actually in your working copy, what's on disk, and what you're seeing in your development, in your editor. Or rather, it represents the last version in the repository that you're making changes to. Your working copy obviously will have additional changes until you go ahead and commit them in. And then head will point to that new.
So there's not a head for each branch. It's whatever your currently checked out branch.
Right. The terminology is a little confusing because Git does talk about branch heads, meaning in this case the branch head for master is this commit right here. The branch head for dev is this one. But when you see head in all capitals, that's a specific term that Git uses, and there's actually a file on disk if you go poking around in the .git folder, which I would encourage you to go ahead and do. It's not especially dangerous to look at the contents of files in there, and at least a few of them are relatively readable. Head represents usually it's what we call a symbolic reference. It's actually just a pointer to another reference, usually to a branch. So we know because head is pointing to the master branch at this point, Git knows that when it goes to check something in, it should update the master branch to point to that new commit that you just did. So it kind of does a little level of indirection. All right, so here's a couple of commands I was talking about earlier. Stat is just my shortcut for status, and it just gives me a real short summary. In this case, it gives me the name of the branch that I'm on. If there's any other branch-related information, like this is a local branch, so it means it's part of my repository. Usually, if you clone your repository off of someone else's, such that when you make changes, you'll occasionally push your changes back up to like the master repository that your group is working with. Your master branch will be tracking a corresponding branch in that upstream repository. If there are differences, if you're ahead or behind that branch, meaning that other, ahead of it meaning that you've made changes locally that you have not pushed up to the central repository, or behind meaning that other changes have been made to that repository that you haven't incorporated into yours yet. It will give you a quick summary of that status here as well. and then any files that have changed. So any files that are modified either in your working copy or in the index or staging area that you, when you're preparing to make a commit into the repository, you'll set a group of files into the staging area, get those exactly the way that you want them, and then commit that set of stage changes. I'll show some examples in a little bit here of how it indicates the status of each file. And this is also where I was talking about the untracked files. If you have additional files that Git doesn't know anything about, it recognizes that they're there, but it doesn't know the status of them, it'll also list them off here unless you include that additional option to say, I don't want to know about them, just tell me about the ones that you're in control of. So the log command here, I've got two versions of it. The log A command here, and I actually truncated this just a little bit so it fit on screen a little bit better. Log A is the one that I use most often, and the A stands for all, which means that it will tell me about all of the branches that I'm working with at the moment. So oftentimes, if I'm working with both a master and development branch, I want to be able to see where within the tree both of those are pointing to, so I can see the differences between them, and if I need to get them in sync with each other, for instance, I'll know what series of changes needs to be involved in that process. So this particular format, it's kind of hard to see it over on the side here, but there's a little set of lines and asterisks, the asterisk indicating where this line within the, so each line represents a commit in the repository. It tells where this line fits into the graph over here. So you can see we've got this initial commit here that corresponds to this one at the bottom here. And these numbers here are what are called the hashes or the object IDs, which is how Git keeps track of things. And those IDs are actually based on the content. So as the content changes, those IDs will change. So they're actually very intrinsically tied to exactly what's in that commit, what that snapshot looks like. And I just copied the first 4 digits of that for each of these in here. The second number, in the case of the log T version, is the tree ID. So the commit ID records all the metadata about who did the commit, when they did it, the log message, and so on. So if I make that same exact commit with the same exact set of files, 2 seconds later, I'm going to get a different ID value because some of that metadata changed because the exact timing of that commit is part of the value that gets incorporated into that ID. The tree, on the other hand, represents just the content. So if you commit the same set of files, you will get exactly the same tree ID value. So I kind of put these in here, these values, just so we can kind of track what the log output looks like compared to the pictures that I drew of it to try and make it a little bit easier to look at. If you were to try and recreate the set of steps that I did here to kind of follow along with my example, you will see different values for these top numbers because you have different name and email address, different dates and times, and things like that. But you should, if you get every little bit of it right, if you just copy and paste these things, you should see exactly the same values for these tree IDs because you've got exactly the same content. And that's actually important because that's part of what allows you to do distributed development and push things back and forth with other developers and know that you've got the same content that they do because those are globally unique values. This line down here represents the initial version, so this is newest to oldest. That's represented by this box here. And then this little branch, so there's a little line here, it's not hard to see, going over to the right just a little bit here, and then following this sequence of changes where I added steps 4 and 5 and 6 and went back and fixed a typo. That represents this sequence of changes here on the development branch, and you can see the development branch is currently resting on this commit here. I'm going to start with 423. And then the other line coming off of this asterisk here just goes straight up to this top commit here, which is corresponding to this line here, which is where my master branch is currently located and where I applied the version 1.1 tag, and also where my head is at the moment, which means that master branch is what I have checked out on disk. And that's the one I'm working on right now, until I switch to a different one. So yeah, really the only difference between these two formats is that the T doesn't automatically include the all flag, so I put that in separately there, but it includes that extra information about the tree. So the commit ID, tree ID in the case of the tree version, the list of references, tags, or branches that are pointing at this one. Quick summary, basically the first line of the commit message I put in. This is kind of considered to be best practice that you ideally want to have a relatively short, like 50 to 60 characters at most, summary of every change that you do on the first line, because a lot of the Git tools will try and display just that content of that first line. So if it fits in a relatively small space, it makes it a lot easier to view a summary of a sequence of changes. And then this is Git's human-friendly version. In this case, it was telling me at the time I ran this command that this commit had been performed 5 hours ago, and then information about who did the commit. And then in this case, I just gave it a -1, dash any number, tells it just only show me the first commit, or the first n commits, however many you want to see. If you just want, if you've got a project with a lot of history, you only want to see the last 5 or 6, for instance, you can limit it that way. There are boatloads of options, many of which I don't even understand myself. Git gives you just about every possible way you can want to slice and dice which commits you want to see and how you want to see them and so on. I recommend you find a few that suit your purposes most of the time and stick with those until you desperately need something else, and then you can dig into the reams of documentation that they provide on those things. I don't expect to ever gain mastery of the whole set. All right. How am I doing on time? I'm probably running a little longer than you had in mind. I'll try and go through this, through our system a little relatively quickly. Okay, this is the one I was looking for. All right, so I just concocted a quick example here. So git init is the command you might run to initialize a new repository. If you're pulling from an existing repository, you'd use the git clone command, which can pull it across from either a local copy or across the network to a variety of workloads. In this case, I just used the cat command and redirected the output into a simple text file. So my initial content was, step 1, step typo, and step 3. I added that file to my staging area, and then I went ahead and committed that file, and I just provided the commit message right on the command line here so we can see everything I'm doing, and call it initial version, which is the message you may have all seen in the logs earlier. I went ahead and applied a tag. In this case, I actually provided a description for the tag as well as the brief name, so that because at that point, this was that initial commit that I just made, I went ahead and applied the tag to the commit I just made. And then I used the checkout command with the -B option to create a new branch called dev and immediately check it out to switch onto that branch. So at that point, the dev branch pointer is pointing to that same commit that I just created. And then any additional ones I created at that point would start creating this new line. So I concatenated a couple of lines onto the end, step 4 and 5, created a commit to add steps 4 and 5 that created this box right here, this commit. Created another one to add a 6th step on, committed that. And then this is actually just a quick little script for a line editor. It's the easiest way I can think of to just stick it all on a command line rather than trying to interactively show walking through an editor to fix my typo that I created when I created step 4. So it just ed is just a little line editor on Unix systems. So I just edited the file and fed it a command to just go into line number 4 and fix the spelling. And then committed my fix for that typo here, which created this version right here. At that point, I went over to the master branch and fixed my typo back on step 2. using a similar technique, and then made that commit. So at that point, master was still pointing back here, so that created this version right here. So now I've got two separate versions with separate sets of changes on two different branches. And this is pretty much the basic setup. You know, like they say, Hollywood only has 7 different stories that they keep telling over and over. This is probably the opening line to every Get horror story. I was working on this branch and I made these set of changes, and someone else was working on this branch over here and made their set of changes, and when we tried to put them together, all hell broke loose. So we're going to quickly run through the few different ways that can happen. All right. So the simplest, as the stat and log commands, the simplest version is going to be just a simple merge. So what I did at this point, the diagram shifted around just a little bit here. The sequence of commits on the dev branch was over on the right. I just moved them over onto the left side here. But those two green commits that were the end of the master and dev branches are also located here. So our dev branch was here and master was here. So I switched into the dev branch and told it to merge the master branch into my dev branch. So what it's going to do at this point is it's going to go back and find the common ancestor, the point at which these two branches held the same content. And it's going to find what has changed on the master branch since then and apply that set of patches into my content in the dev branch and create a new commit automatically, assuming that everything merges together without causing any problems, which we'll cover in just a minute, and pointed the dev branch to that new commit. So that's what that was all incorporated into the merge command here. And again, I just ran the log command. You can kind of see that same set of commits on the one side and just a couple of commits on the other side, which started at a common point, branched off, and then came back together when we performed that merge. And this comment that was applied to that commit was automatically generated by Git. Just you have the option of going in and overriding that if you want to, but in most cases you just say, I just merge what was on the master branch into my dev branch. This is ideally the way every merge would happen. Git does everything automatically, and life is good, and you don't have to do any extra work. So what happens when things don't go quite so smoothly? So here's those same two commits that we had earlier, and here's that merge. So we put them both together on the dev branch. I went ahead and created a couple of new commits on the development branch. I added a couple of sub-steps underneath step 2. Actually, first I added a sub-step on the master branch, called it 2A, because I was already on master here, made some edits and committed sub-step 2A. And I actually went ahead and tagged that version. And then I went to switch over to the dev branch and made a similar edit there, created a different sub-step, called it 2.1. And then, so that represents this change here on top of the merge that we did in the last screen. And then I went ahead and added a new step on top of that. So dev at this point is pointing to this version, which has one version of the fix. Master has a different version of the fix, and dev also has an additional step that I added. At this point, I also used the branch command to create a new branch called new steps. So this might represent another developer that was maybe looking at, did a review on the code that I did on my dev branch and decided to start adding some new functionality or some new content starting at that point. And we'll come back and see what happens with that when that developer starts to push their content back in just a moment here. So again, this is just and I kind of put this in so you guys can kind of go back and look and try and compare what these different diagrams look like at each point along the way. This is just the log output that corresponds to the diagram over here. At this point, I went ahead and attempted a merge. I was on the development branch right here. I asked Git to merge the content of the master branch that differed from the development branch. And at this point, it would actually produce some output here telling me that things didn't go quite as smoothly as I might have hoped. I couldn't fit all that content in here, but at that point, I was able to run the stat command, and it tells me that I'm on the dev branch, and it lists the steps file and the U's here that you can just barely see. 2 capital U's means that there were conflicts in that file. So because I added a sub-step in the same position on both files, Git doesn't know what to do with it. It doesn't know, should it take the one, should it take the other, should it take some combination of the two. So at this point, this is where I need to step in, and this is usually where people get really confused about what to do at this point. So at this point, you have to fire up your editor on that file, and you're going to find in amongst the rest of the lines in the file something that looks a little bit like this. These are the diff markers. So the lines in between the left pointing arrows and the equal signs, in this case, represents the content in my head, which is the dev branch, and the stuff in between the equal signs and the right pointing arrows is what was on the master branch. So what I decided to do in this case was I just kept both of them, and I believe I changed this to the sub-step B instead of sub-step 1, and just made sure they were in the correct order. Saved the content of that file after I finished the editor, removed the marker lines. You want to make sure you get rid of those, because obviously those are probably going to cause compile errors in real code, because they aren't valid syntax in pretty much any language by design. And then after saving the changes to that file, I went ahead and added that file into my staging area. So at this point, Git has prepared a new commit that represents the merged content, with the exception of the parts that it didn't know what to do with. So when I finish sorting out those changes, I need to go ahead and add those to that staged content, and then go ahead and complete the commit. And the commit, when if you don't supply a commit message along on the command line, it will automatically fire up an editor for you to do that. In this case, it was already pre-populated with the default merge message. So I can modify that if I need to, or just take it as it is. And having done that, I've now created this new commit here from these 2 versions that represents the combined content from both of those. And again, the dev branch is now pointing to that new merge commit. Master is still pointing where it was before, the latest version that I committed over there. And I still have this new branch that I created that's pointing to the pre-merged state from the development branch. So at this point, our prodigal branch starts wandering off in a different direction. I created a sequence of steps here on that branch from where we started down here. Added several more steps and at least one more typo. I added one last step, noticed my typo, and went back in and did an edit to fix my typo on step 8. So that sequence of commits, I now want to incorporate that back into my development branch and eventually into our master production branch. Any questions at this point? So far so good? So instead of doing a merge, I decided to use a different technique here. I'm actually going to attempt to demonstrate this live here, because it's a lot easier to walk through the process than to try and do this with a set of screenshots. But basically I'm going to use what's called the rebase command. And people who aren't so sure about Git, or who are outright passionate haters of it, will scream and cry about this command probably more than anything else, because what rebase allows you to do is actually, in a way, rewrite the history of your project. You can actually go back in and take a sequence of commits and either pull them out of the graph and transplant them somewhere else, or in some cases even do even more extreme manipulations. So where I had a sequence of 3 commits over here that represented one set of additions, a second set of additions, and then a fix to the first set of additions, I'm actually going to rewrite that into just 2 commits that represent the 2 addition steps.
Yeah, quick question. So I don't have much knowledge to Git, but as far as I knew, like garbage collection was the only thing that's really destructive. Would rebase be destructive? Could be as well, potentially?
In a way, yes, but not really. Ultimately, Git saves everything. It never forgets anything that you've done. So that, in this case, I'm actually creating 2 entirely new commits because the metadata about which previous commits they were based on, where they live, where they exist in the tree, that's all different. The old ones are still there. The only trick is that nothing's pointing to them anymore, so if you had to go back and find them, it might seem like they're lost because there's no friendly name like new steps pointing to it anymore. But it turns out actually Git even remembers the fact that those once existed, in fact the fact that they do still exist, and the fact that that branch used to have those commits, and I'll show you in a little bit how you can go back and find out how things used to be if you ever need to, if you realize you've gone down a terrible path and want to backtrack. So the rebase commit, I'm going to skip over. If anyone's interested, I'll actually show you the interactive rebase. Basically what it does is gives you a list of those commits and lets you decide what order you want to apply them. In some cases actually combine commits together. So the one where I added the content and the one where I later, a couple commits down the line, fixed the content that I added can actually be combined into a single commit that just adds the correct content one time. And that's basically what these 2 commits represent at this point, is 2 adds of correct content into the, and now the new step branch is built on top of the end of the development branch.
So you could rebase your development branch to clean up something messy, and then when you push,
Yes, and when you have a nice,
it looks
clean,
pretty.
understandable, easy to comprehend set of commits that doesn't involve a bunch of spaghetti changes, interspersed amongst each other, you can push that out to the rest of the development team, which is going to make it a lot easier for them to understand what you did. Then the remaining commands here basically just switch from my new steps branch onto development, and at this point, when I have to merge the new steps branch into development, we'll end up with what Git calls a fast-forward merge. It doesn't really need to merge anything at all. All it needs to do is just say, development was here, there's a linear sequence of changes after that, we'll just move the pointer. Development branch now ends here instead of here. And so there's no possibility of any conflicts because there's no merging of information. They call it a merge, but in reality it's just a move of that pointer. And then same thing would happen with master because we have a linear sequence of changes. When we say merge the development branch into master, it'll just move that pointer to the end and say this is the new master branch. And then somewhere along the way there I forgot to add it to my diagram, but we went ahead and decided that's our new version 2.0 and created a tag for it. Last trick then, like I said, Git never really forgets anything. You did mention garbage collection. Git has a procedure that runs on a regular basis and gets rid of old content that's part of its database, if you will, that's no longer being used. However, it's even you can obviously tweak to your heart's content how long it waits for doing that. So I believe it will wait a minimum of 2 weeks before it ever gets rid of anything that's not being used anymore. And in some cases, depending upon,
right?
what's that?
You can just run git GC, right?
You can, but even when you run that, it'll only get rid of the things that have passed its thresholds for the amount of time it waits. You can go in, like I said, and tweak those if you want to, but it will never, there's no command that'll just say, get rid of everything that's not being used right now. Because in many cases, you want to have a little bit of safety. And frankly, Git is so efficient about how it stores things, it's a very minor burden to keep extra copies of things around. So what the reflog command lets you do is every time that branch pointer moves from one location to another in that tree, Git writes an entry into the log. So we can actually get an entire history of where that pointer was pointing. So I can actually go back and say, here's where I initially created that branch off of the dev branch. Here's where I added 1, 2, and then 3 commits onto it. And then here's where I ran my rebase and basically discarded these 3 commits from the branch and created 2 new ones. If I decide, you know what, that rebasing process that I did didn't work out so well, I can actually go in and tell Git, reset that branch pointer back to the way it was before I did that last operation. And all of those changes that you made are now back available again. So as long as you do this within a couple of weeks, as long as it doesn't take you too long to realize that, to the point that Git will purge that information out, it's always there somewhere, and the reflog command is probably the key tool for finding those seemingly lost commits. Yes?
Actually, I think you almost answered my question. How does Git decide that you're not using it anymore? But it's because you did a rebase and you like threw away a couple steps or
Right,
something?
yeah, so if
'Cause
I,
I don't want, like, sometimes I won't get to something for a month. And,
right.
To have it like delete stuff for me would be scary.
Right, so in this version, I have these 3 commits, and then and those still exist when I do the rebase, but the process of the rebase creates 2 new commits that are now, instead of being based on this version, are now based on this version, and a set of, a sequence of changes from there, and it just changes this pointer to point to those new ones, which are on the next slide. These still exist. So if you need to go back, you can use the reflog to find out where was new steps pointing before it.
But so when is it gonna throw those away? Is that configurable?
That is configurable, so I don't really have a rundown, but certain things it'll throw away as long as no branches are pointing to them. Certain things it'll wait a little bit longer until no ref logs are pointing, because ref logs get cleaned out every so often as well. They don't go on forever and ever and ever. I think it waits something like 3 months by default before it starts purging old ref log entries. I think it waits 1 month before it purges things that no branch is pointing to, and I think it waits 2 weeks for something that not even a ref log is pointing
And
to.
they call it a purge or something, so we could like maybe look up what.
You can use, there's a purge command that you can go in to get rid of information on a somewhat more drastic level, but usually it's the GC, or garbage collection command, that does that, and actually that command automatically runs when you do certain operations. So if you can live your entire life in Git and never have to run that command by hand, it'll automatically run periodically.
When we develop code in Google App Engine, so does Google provide some kind of a GitHub or some version control tool as part of?
There's nothing connected directly to App Engine. You'd have to just pick whichever one you want to use, either doing your development locally, or if you need to share with other people using something like GitHub, Bitbucket, or if you can arrange to just push changes directly between each other's repositories depending upon your network setup. But yeah, Google Code does provide Git hosting, I believe,
The
right?
Subversion.
I think they do Git now
Do
too.
they go Git now?
So there's a bunch of options out there, and unless you're doing some significant development, ever having to pay for Git hosting somewhere is probably not necessarily on the map, at least for personal level stuff, and depending upon how willing you are to let the rest of the world see what you're doing.
Are you done? Are you taking questions now?
Any questions? Yeah, or I can take questions afterwards. I think Eric's getting anxious. It's almost past his bedtime, so we better.
Okay. Thanks a lot.
Mm-hmm.